Okay, so there's a lot of numbers going on here. Google Sheets is probably going to be the easiest way to do this. You can click this button, just like we did in previous videos, to copy the data over to a Google Sheets file. So this is the data we want to make a scatter plot for. Okay, so if I click and drag, then you can click Insert in Google Sheets. It's a similar process for Microsoft Excel, but we want to insert a chart, and I think Google Sheets is going to be good at guessing. Yep, it knows we want a scatter plot. And so let's just check the x-axis. Per capita GDP, is that their x-axis? Yep, GDP is on their x-axis. So we just have to figure out which one matches the dots that we have in our scatter plot. Best one, man, I don't know. None of them are absolutely clear. 1, 2, 3. Oh, there's a few outliers over here. Yeah, because the scale is different. You know, they start at 200,000, they go to 550,000. There's a few outliers over here. That's probably going to be the easiest way of picking the right graph. You can actually change edit chart. So click that dot, click edit chart, and then there's a way to change the x-axis to make it look more like these. Horizontal axis. You can scale by, what are they going by? Every tick is 1, 2, 3, 4, 5, 6, 7. Every tick is 5,000 units. Oh no, I just lost it. We gotta go back in. So we can change, if we click customize horizontal axis, right now it is scale factors auto. Man, I want 500,000, but it won't give it to me. Oh, okay, that's just changing this down here. Okay, maybe we're just going to have to pick based on what we see here. I mean, these dots would be a lot tighter. We need those two outliers. One's near 450,000 on the X, and looks like 1,800 on the Y. So we're looking at a little over 450,000 on the X. Looks like this is our winner here. Okay, and I'm getting that because I'm looking at where the outlier dots are. This one is a little bit past 450,000, and it's at 1,800 on the y-axis. So that's good. That's that dot right here. And then the next dot over here is close to 500,000 on the x-axis and close to 1,300 on the y-axis. So that's this dot here. 1,300 on the y-axis. That's not matching up. Because, oh, it is, because this is 1,000, so that is 1,300. None of the other ones have dots there. So I guess the best way to pick the right one when you're looking at a chart in MyMathLab is to find a couple of particular dots that are unique to the other ones and see if they match up. So what kind of correlation is present, if anything, here? It's tough to say because those are kind of outliers. It's because when it's going perfectly straight up, like this one has no correlation. Okay, if two variables are going perfectly straight up or perfectly left and right, there's no correlation. This one, we'd have to say there's some sort of negative relationship. Positive, because it's increasing from left to right. Start over here, the numbers start low, and if you move to the right on the x-axis, the numbers are getting bigger. They appear to be correlated, and whether it's strong or weak, I'd have to go with strong just because of how close the dots are to each other. But that's a debatable point, you know? Like what's strong and what's weak. Even if you calculate a correlation coefficient, R, that's still not necessarily strong or weak depending on the situation. But Part C, suggest a reason for the correlation or lack of correlation. So GDP and defense spending. As GDP goes up, as the amount of money like a country can be measured as producing wealth, okay, the amount of money a country has goes up in one sense of the word. Defense spending goes up. So as the country has a higher GDP per capita, the more it can spend on defense spending.